Today we're talking about multiplication properties of exponents. There were multiplying powers with the same base for every non-zero number a and integers m and n. A to the m power times a to the n power is equal to a to the m plus n power. In other words, let's say we have 3 to the 5th power times 3 to the 4th power. This is equal to 3 to the 5th plus 4 power, or 3 to the 9th power. This is the rule. Let me show you the long way why this works. When we're multiplying 3 to the 5th power, this means 3 times 3 times 3 times 3 times 3. When we're multiplying 3 to the 4th power, this means 3 times 3 times 3 times 3. How many 3's do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why this is equal to 3 to the 9th power. Let's say we have h squared times h to the 9th power. With the multiplying powers with the same base property, we know that this is equal to h to the 2 plus 9, or h to the 11th power. This means h times h, and this means h times h times h times h. If we count all these, do we have 11 h's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. H to the 11th power. We have to rewrite each expression using each base only once. This means 5 cubed times 5 to the 6th power. The property of multiplying powers with the same base says that we have to keep our base and add our exponents. So this means 5 to the 9th power. This is our expression, rewriting our expression using the base only once. Try another one. We have 2 to the 4th power times 2 to the negative 3rd power. What would this equal? What's the base? 2, and the exponent 4 plus negative 3. This means 2 to the 1st power, or just 2. Let's say we have 7 to the negative 3rd power times 7 squared times 7 to the 6th power. What do we have to do? What is our base? 7. And we have to add our exponents, negative 3 plus 2 plus 6. This means 7 to the 5th power. If we have to simplify 2n to the 5th power times 3n to the negative 2 power, what is our common base? N. And the exponent on this n is 5, and the exponent on this n is negative 2. What about the 2 and the 3? 2 and 3, they're not the same base, so what is the operation telling us to do? Multiply. So 2 times 3 is 6. And what do we do when we have exponents with the same base? We add the exponents. So this means 6n cubed. Let's try another one. Let's say we have 6y squared times 3y cubed times 2y negative 4. What is the common base here? The y. What do we do with these exponents? We add the exponents. What do we do with the coefficients, 6, 3, and 2? We multiply them. 6 times 3 is, and 18 times 2? 36. If we add the exponents, y 2 plus 3, 5 minus 4, 1. If we have to simplify c to the fourth power times c to the negative third power times c squared, we have to add the exponents of the terms with the common base. In this case, the common base would be c. So this means c to the 4 plus 2 power. What about the d to the negative third power? It just stays, right? So this would equal c to the 6th power d to the negative third power. But when we're simplifying, can we have negative exponents? No. What do we do to the negative exponent to make it positive? You have to put it in the denominator, right? So this means c to the 6th power over d cubed. We have to simplify 5x times 2y to the 4th power times 3x to the 8th power. What is our common base here? X. This x to the 8th power. What do we do with the coefficients? 5, 2, and 3. We multiply them. 5 times 2 is 10 times 3, 30. Then we've got the x. This x has an invisible 1 plus 8. What about the y to the 4th power? It doesn't have anything in common, so it just tags along. This equals 30 x to the 9th power, y to the 4th power. We're multiplying numbers in scientific notation. We would multiply 7 times 4. That would equal 28. And then, isn't this a common base, the 10 with the exponent 2 and the 10 with the exponent 5? So that means we can add the exponent 2 plus 5. This means 28 times 10 to the 7th power. But is this in correct scientific notation or not? No. What do we have to do? We have to move the decimal one space, and this becomes 2.8. We have to add 1 to the exponent times 10 to the 8th power.